Welcome to Lesson 2 in Arduino, and in this lesson, we're going to learn how to use our very first sensor. If you think about things in life that use sensors, they really make electronics more useful and also more engaging. So it gives you a chance to interact with them and they can respond to you. So it's one of the big draws of electronic interactive art is that you are part of the artwork. And that all involves using sensors. What's beautiful about sensors is that they can take input from the outside world, and then they just boil it down to a very simple voltage reading, and the Arduino reads that voltage reading and can respond to it by changing the electronic signals it sends to other components. So the first sensor we'll learn to use is a potentiometer. You'll pull this out of your kit, and let me get an example of one for you so you can see what it looks like. Got one right here. This potentiometer is like a little black stick on top of a wheel, and there's 3 pins sticking out of it, 2 on one side and 1 on the other. And you can turn the knob. It's not a super smooth turning thing, but you can turn it a little bit. So this sensor responds by turning. And what's inside it is there's a couple of variable resistors in there. So the idea is on the 2 pins on the one side, you're going to put a 0 to 5 volt signal across them. And then the pin in the middle, its voltage is going to change depending on the variable resistor inside the knob. So as you turn it, that resistor actually changes its resistance, and that changes the voltage on the middle pin. So your resistor is this form factor. Some resistors also come in this form factor, also with 3 pins, and the one in the middle is the sensor pin. That's the one that you read the voltage on. So I'll show you how to place both on the breadboard. For the one that you probably have, put it on the breadboard so that the 2 pins are on one side of the valley, and then the other single pin is on the other side of the valley. It may not push into the breadboard all the way, but you should be able to fit it into the breadboard snugly enough that the pins are making contact with the metal inside the breadboard. So 2 pins on one side, 1 pin on the other side of the valley. You want to make sure each pin has its own numbered row, so don't rotate it so that any 2 pins are in the same numbered row. In my example, I've got 1 pin in row 15, 1 in row 13, and another one's in row 14, but it's on the other side of the valley. It's not connected to anything else. For the other kind of potentiometer, you can put the 3 pins on the same side of the valley. Just make sure that they're all 3 in different numbered rows. Numbered row, numbered row, numbered row. Okay? Now the way that we wire this up to the Arduino is on the 2 pins that are on the outside. One of them is going to go to ground, and the other is going to go to 5 volts, and it doesn't matter which is which. So I'll show you the most common way to wire these up to ground. So first of all, pick one of the pins, and you're just going to take a jumper wire and go from the numbered row that goes to that pin over to the ground rail. Okay, so now that's connected to ground because the ground rail is already connected to ground on the Arduino. Then the pin that goes in the other numbered row, we're going to connect that one to the 5 volt rail, and I'm going to change this color to red just to show that it's a 5 volt connection. And then I'm going to take another jumper wire from the 5 volt pin on the Arduino. You can see it right here. It says 5V, and that's going to go over to the 5 volt rail. So I only have one thing in this circuit that's connected to 5 volts, but if I ever have multiple items that need to be connected to 5 volts, this is just a good practice to take 5 volts from the Arduino and electrify the whole positive rail, this whole red row. And then ground electrifies the whole blue row. Take extra caution, make sure things are not plugged in at this point, and just make sure the plus 5 volt is in one row, and the ground is in the other row. You do not want to connect 5 volts and ground together in the same row. You'll short out your Arduino and you will fry it. Okay? So we got ground going to 1 pin on one side of your potentiometer, and we've got 5 volts going to the other side, the other pin of your potentiometer. That leaves the middle pin. So this one's going to be connected to a pin where we can read what voltage it is, and those are these analog in pins right here. These are your sensor pins. So take another wire, and you're going to find the middle pin on your potentiometer. Take a jumper wire from that middle pin's numbered row over to analog 0, A0, on the Arduino. And I'm going to change the color of this so that it stands out a little bit more. Let's do white. And I'm just going to make a couple of bends in this wire so I can see it a little better. There we go. Not like that. Not like that either. There we go. Okay, so on the middle pin of the potentiometer to A0. Outside pin, 5 volts. Outside pin, ground. Middle pin, A0. The wiring is now complete. We're going to go over to the code and I'll show you how to respond to that pin. So in the code, what we're going to do is, first of all, we're going to turn on the serial monitor. The serial monitor is a great debugging tool so you can see what information is coming from your sensor if you ever have trouble with it. The way we turn on the serial monitor is with one simple line of code. Find a blank line anywhere inside void setup. Look in between this curly brace and this curly brace and just add a blank line anywhere in there. And on this blank line we type in serial with a capital S dot begin, all lowercase, and inside the parentheses we type 9600. This 9600 is called a baud rate. That's how fast it sends ones and zeros from the Arduino to your computer. And the Arduino uses 9600 ones and zeros per second by default. Okay, then we're going to go add a variable that we can use to read the signal coming from the potentiometer. A potentiometer in electrical engineering is often called a pot, so we're going to use that as the variable name. The way you declare a variable in Arduino is you have to say what type of variable it is. So this type of variable is an integer or an int. We put this first line of the code all the way before void setup, int pot semicolon. So this declared a variable called pot and it's an integer. And we'll put that at the very top of the program before void setup. Next, we're going to go inside void loop. So go find your line, the first line of actual code inside void loop, and just add a couple blank lines before that. So it should be after this first curly brace, not before the word void loop, right here, like the first blank line of code. We're just going to read what the potentiometer is telling us in the Arduino, and we're going to respond to it in the serial monitor. So the way we do that is we say pot, our new variable, equals analog read with a capital R, and in the parentheses we're going to say capital A 0, and then semicolon. So what that does is it reads the voltage on pin A0, and it's going to turn that into a number between 0 and 1024. 0 is no voltage, and 1024 is 5 volts. And we will write that to the serial monitor. Serial.println parentheses pot. Okay? This program isn't going to do anything with the blinking lights yet, but we can see what our potentiometer is reading. At this point, I'm going to save the code under a different name. So let's save this as pot. It sounds really silly, but it actually is a word that electrical engineers use all the time. We'll upload the code. Okay, and right now I've got a light that's still blinking, but this is normal. And I'm going to turn the potentiometer, but I'm also going to turn on the serial monitor. In your coding environment, if you're in Arduino IDE, the serial monitor is a little magnifying glass in the upper right. And if you're working in the Chrome app, you'll see an icon on the left that also looks like a magnifying glass, and it says monitor. So use that button. And then as I turn the knob here, you can see I'm getting different readings from the potentiometer. It goes all the way down to 0, or, there we go, it took a few minutes to get a reading, or all the way up to over 1000. See, now it's at 1023, which is as high as it gets. And it looks like I have at least one wire that's a little bit glitchy here, so it's giving me funky readings. Okay. It's only reading it once per second because as it goes through the loop, it's reading what's on the potentiometer, writing it to the serial port, and then it blinks the light. And in between this blinking, it delays for one full second, 500 milliseconds here, 500 milliseconds there. So I'm only getting a reading on the serial monitor once per second. Yeah, it's important to know it's only going to be taking a reading when it comes back to the beginning of loop. So now I'm going to use that number that I'm getting back from the potentiometer, and I'll use that to set the speed at which my light is blinking. So going back to the code, let me close this, instead of doing a delay of 500 every time, I'm going to do a delay that's as long as the reading that I'm getting from the potentiometer. So instead of 500, I will write pot, and also put that in right here instead of this 500. And now when I upload the code again, adjusting my potentiometer will make the light blink faster or slower. I'm going to hold this over here and see if I can. My cables are a little short, so we'll see if we can get this to reach. I'm going to turn the camera a bit. Okay, so, alright, I'm going to turn on the serial monitor too so I can see what delay it's reading. So that's a delay of about 500. It's about as fast as it was going before. And as I turn the knob this way, it's turning the number down. You can see the light blinks faster and faster. And then as I turn the knob the other way, it's going to start blinking slower and slower because it increases that delay. So now you can make your computer program respond to input from the real world. Just by turning that potentiometer knob, we change a variable, and we can make that variable change anything in our code that we want to change. So experiment with that, and see if you can also get your potentiometer to adjust the speed of 2 lights blinking. I hope you enjoy working with sensors, and next time we'll learn about additional sensors that you can use, and also how to use colorful lights. Thank you.